My name is John Caldwell, and today I would like to talk a little bit about the design and installation of a residential lawn sprinkler system. This is a 20-minute lecture / presentation for fire services course delivery. Before I get started, I'd like to tell a little bit about myself. I currently work in the fire service, but before this, I worked at an irrigation company for 10 years, 7 of that being a supervisor. We did a large array of projects from large commercial buildings, installations, repairs, to small residentials from repairs and installations. All right, so let me begin. Our first bullet point is we're going to demonstrate the knowledge on how to design a residential sprinkler system. First of all, we'll do some basic definitions, starting off with sprays. A spray is a sprinkler with a fixed pattern, not usually designed to operate above 30 psi. These are the common sprinklers you see out in people's yards pretty much, and they continue to spray a small little pattern. And all right, our second type we're going to talk about definition is a rotor. It's a type of sprinkler where a stream of water moves back and forth over the area being watered. These are the larger ones you see that cover larger areas, bigger yards and stuff like that, that oscillate real slowly. Drip irrigation is that long brown tubing with the small holes in it, and that's designed to concentrate water at a low volume for a long period of time, 30, 45 minutes, hour and a half, something like that. So here are some pictures. That's your basic spray right there. Here's a picture of your basic rotor. And then we have a picture of drip irrigation. Okay, identify your local irrigation codes and requirements for the following. This is important before you start any system, because if you don't, one, you get to contaminate the water system, and two, if you're doing stuff illegal, if they find you, they're going to fine you and whatnot. So it's good to know this first before you get started. Okay, backflow preventer. That's that big brass thing you usually see on the side of people's houses. And most counties require this backflow to be brass, and it has to be 12 inches above your highest sprinkler head. The theory is it prevents cross-contamination. So, a rain sensor. You've all seen the little things off the side of the eaves. Every new yard now has to have a rain sensor. It has to be in view of the sky. It can't be covered in trees and stuff like that. And it has to be out of the AC venting. They say there's the AC dries it out too fast, and it'll cause it to misread. Distance away from the house. A lot of the sprinklers, a lot of the codes require the sprinklers to be 12 inches away from the house. What this does, the theory behind that is, they think the water tends to soak back into the foundation and will deteriorate it. So that's why that code was developed. Pipe depth. It's really hard to say pipe depth, but usually majority of the residential houses, probably a good idea to try to get it around 12 inches deep, something like that. This will help prevent any things from happening to it. If it's buried too shallow, it will tend to break more or whatnot. Define a GPM. Okay, GPM is gallons per minute of flowing water out of an orifice. Again, this is going to be important when we're designing our system, so we know This is the basis on how many heads you can put on one zone. In a minute we'll go over zones. Demonstrate how to calculate GPMs at your current location. Okay, what we're going to do is we need to get a 1 gallon container and turn on your water source and see how long it takes to fill that 1 gallon container. And the formula is 60 divided by the seconds it takes to fill that one container, which will give you GPMs. 60 divided seconds will give you GPMs. Define a sprinkler zone. Is a separation of sprays or rotors based on the GPMs available. Example, if we have a system, a GPM of 15 gallons per minute at a residential house, and your average rotor takes about 5 GPMs. If you divide the 15 divided by 3, that'll give you 5 rotors. So you can put 5 rotors on that zone. A typical spray zone holds probably, or will run about 10 to 15 sprays. A typical rotor zone, 4 to 7 rotors, something like that. That's just what I've found over the years. Demonstrate the ability to correctly space the sprinkler heads apart. It's very important when designing your system. Usually it's designed to overlap to get the best coverage. Now a spray is in between 4 and 18 feet apart. And that's all dependent on what you have to work with and whatnot. Rotors, they're anywhere between 20 to 45 feet apart. And again, to space them out correctly, you want the rotors to overlap each other. This will give you 100% coverage in your yard. Laying out the system. Basically, there's a simple way to do it. They have colored flags for sale. What these colored flags do will give you your different zones. So, example, a yard full of blue flags will give you, that'll be your blue zone and whatnot. Footsteps are standard for a quick measure. One large step will be about 3 feet, so that's something that can speed up the process when you're designing your system. Sprays are in smaller areas and where the water can be concentrated. Rotors are in larger areas. Water takes longer to cover the same area. Bullet point number 2, demonstrate the correct way to install a residential sprinkler system. Okay. First of all, we'll start with some basics, maybe just like a checklist of what you would do from start to beginning, and then we'll break those down in a minute and go over them. First of all, we'll lay out the system, find and hook into the main line, trench out the yard, build a valve box, lay pipe and glue it together properly, put in the sprinklers, bury the yard, and last but not least, we're going to test everything and make sure everything runs right. Define trenching. I know it sounds basic, but as far as this project concerns, we're going to define it as to excavate enough dirt to put a piece or multiple pieces of pipe in. Define a trencher. Again, this is basic stuff, but a trencher is a gas-powered machine used to help excavate the correct amount of dirt you need to put the pipe in there in your given yard. The average residential home only needs a trench about 12 inches deep by about 4 inches wide. Some cases the trenching needs to be deeper. Larger commercial stuff, getting off topic a little bit, but the larger commercial areas, they can go down 18, 24 inches deep, even deeper than that they require sometimes. The larger trenchers, they can go like 10 to 15 feet deep. So, there's a picture of the common trench that we used was a ground saw. It was It maxed out about 12 inches deep by about 3 or 4 inches wide. It was powered by a Honda 6 horsepower motor. Define a water source as it relates to a sprinkler system. A water source is where your water will be originating from. Usually pressurized by the county or city municipality, and these are in urban areas. If you live out in the rural areas, you're going to probably have a well, a bladder tank or something like that, or a centrifugal pump. The average pressure for a city line is probably about 20 to 40 psi. The average pressure for a well is 40 to 60. Those can be adjustable by the pressure switches. 20 being lowest, 60 being the highest, somewhere around there. Define a valve box. Is a designated area. A valve box is where we're going to put our valves, the valves that control the zones, and usually is a designated area away from heavy traffic. Okay, usually against the house. Location, it's easy to find, you know a spot, and you want to try to keep them all together. Keep the majority of the valves together if you can. Sometimes it uses more pipe, but in the long run to repair stuff like that, it's good to have them all together in a central location. The actual plastic box actually covers it and protects it also against the sun. Define PVC. PVC is defined as polyvinyl chloride. It is the most common type of irrigation piping. When glued correctly, it heats up and melts the pipe together, and then when it cools, it forms a bond. Other types of piping include galvanized, poly piping, copper, but that's all nowadays probably too expensive to do, and it's really hard to work with. A lot of the older systems you'll find will galvanize and you just can't repair it. It just doesn't hold up as well as the PVC. Describe the purpose of direct burial wire. Direct burial wire, if you have an automated system, the valves operate off 12 volts solenoids. To get current to these solenoids, we need a wire. They use a direct barrel wire. It's a stranded wire, and it's made to be buried in the ground, and it's protected from the elements. This wire is used to transfer electricity from the timer to the valves. An important part of your system. Identify an irrigation timer. Is a voltage distribution box. It separates the zone. It is programmable. Start times, run times, and days to water. The newer ones are all electronic and they can be adjusted to pretty much anything you want. They're super simple nowadays too. Common types are Rainbird, Hunter, and Orbit. The system doubles, the timer doubles as a ground also. It is protected by a fuse, and they do have an indoor and an outdoor type of timer. The indoor being more common, again, it's more protected from things. The outdoors made for larger areas, and they're a little more expensive. Your transformers are a little different, stuff like that. So, irrigation type radio, just put a common type. This is the Rainbird ESP 6 or 4. I'm sorry. It's very common, very easy to use. Describe the correct way to install an irrigation timer. Again, we're going to do this out of heavy traffic, usually indoors, easy to access, less common, but they do make outdoor timers. We're going to talk about that. Common to place near an electrical outlet. Bolted to the concrete or drywall when it's secure up against the wall. And also, they usually go in the garage too. It's just a common place. They can pretty much go anywhere, but garages are very common. Define an irrigation valve. An electric or hydraulic remote control valve in an irrigation system which is activated by a timer. Also called a control valve, or zone valve, I'm sorry. Controlled by 12-volt solenoid. A control valve, here's a picture. This is the Rainbird, our 1-inch Rainbird control valve right there. Okay, to bring it all together, what we're going to do when we're installing this yard, we're going to mark the yard, trench the yard, install a main line, install the valves, install piping, install the heads, bury, and get it test. And then usually at the end we install the timer, the rain sensor, and stuff like that. So, and then at the very end you adjust your sprinklers. Demonstrate the ability to correctly place certain elements of a residential sprinkler system. This basically just say the parts of it, the best place to put this stuff. The correct placement of a valve box, usually against the house, out of heavy traffic. Should place all valves in one box if possible. Easier to repair and find. Behind shrubs, easier on the eyes. You don't want those out in the middle of the yards. People can see them. That's sometimes a big issue. A valve box. That's the common valve box again with the Rainbirds. And what you can see is the main line coming in from the bottom, and the valves are distributing the zones. So that we have a 4-zone system there. Describe the correct placement for the sprinkler heads. It's all going to be basic stuff, but it should be at least placed 12 inches inside the property line. This will help if you have fences or issues with neighbors, stuff like that. If it's inside your yard, you won't be responsible, for repairs or anything. If something happens, if your neighbor does something to you. You want, again, this is basic, but you want the stuff spraying away from the house if you can. You don't want to pound your house with water if you don't have to. It's a waste, and it's probably not good for your house. Usually, you want your sprinklers standing straight up and down. You don't want them crooked or spraying down the water because they're not going to be doing their job. Another thing is very simple. You don't want to plant. You don't put your sprinklers behind, shrubs. If they're not spraying correctly over these shrubs, then they're not doing any good. You're wasting water. You don't want to put a sprinkler behind anything that's going to grow up above it. And again, it's going to be probably about 12 inches away from the house to prevent any damage to the house. Describe the correct placement of the timer. Should be placed indoors, away from the elements. Garage is ideal. Next to a receptacle. You don't want to run an extension cord, 20 feet of extension cord to run a timer. That's kind of probably not safe in the long run either. Usually install it about chest high for easy programming. You don't want it down, up, or something like that. You want it level so you can go out there, be a repair guy, or you can easily set and adjust stuff. Describe the correct placement for PVC piping. PVC piping placement, basically when you're trenching out a system, you're basically trying to find the shortest route to the sprinkler head. This will save you money in piping and time and digging and stuff like that. So you're just trying to connect the dots. There's no rhyme or reason to trenching or the placement of the piping, just whatever is easier for the installer. You want to try to avoid trees and future places that may be excavated. Again, it helps in the long run. You don't want to, like I said again, put that where stuff at the pool. You don't want to put stuff through there if you know a pool's coming in. Again, 12 inches away from house is a safe bet. Describe the correct placement of the backflow preventer. Again, you want to try to keep this close to the house. You want to keep this straight for aesthetic reasons. There's a picture of a brass, it looked like a Watkins 1-inch backflow preventer. Okay, now this is going to go, we have two different types of water, and that usually is used around here. And I'm going to try to identify the difference between reclaimed water and potable water sprinkler systems. Reclaimed water is recycled water that your municipality recycles and delivers. Actually, it puts a meter up at your house also, and it is supplied by the city or county. Again, it's a good thing. It's a lot cheaper. They charge you an arm and a leg for the potable water. Reclaimed water averages, I don't know, somebody's like $7 a month. So it's good on the budget. The difference in the piping, basically the same material. One is going to be, the reclaimed piping is going to be purple throughout, and it's going to have do not drink on it. Very important. You don't want to connect in there, or somebody connect in there and try to get water out because it will make them sick. It is recycled. It has writing that reads reclaim, do not drink. Joins the same way, uses the same fittings. Again, it's just purple. The difference in the main line or shut off. Potable water, you need your backflow preventer. A PVB is required for potable water. It prevents contaminated water from recirculating back into the city lines. That's a big thing. Because if contaminants get in there, it could contaminate everybody down your block, your system, your water, everything. So it gives the owner a manual shut-off. What backflow also does. So if something goes wrong with your sprinkler system, bam, you have a shut-off right there. Reclaimed water, it's already recycled, it's already contaminated. So the only thing you really need is a ball valve for your main line. It gives the owner a system, control if it malfunctions again. Describe the difference in sprinkler heads. Okay, potable system. Standard sprinkler heads can be used. They're usually black. The reclaimed system, the sprinkler should have purple tops and purple bases. Again, that read do not drink. The nozzles on the sprays are also purple. Reclaimed versus standard heads. Okay, there's our purple spray head. There's our reclaimed rotor. And again, here is a standard potable water sprinkler head. Describe the difference in valve boxes. Okay, a valve box for a potable system is usually black with a green top. Now, reclaimed system is purple throughout, base and lid. Again, it reads do not drink. Okay. I think that was all. Thank you for listening to my presentation.